Hello everybody. Today we are going to start new chapter thermal radiation. Throughout the presentation we would concentrate on the following questions or following topics. The first one, what is radiation? What is the nature of radiation? What is radiation flux? What are the various radiative properties? What is an ideal surfaces? We are going to talk about black body. What is Stephen Boltzmann law? Radiation exchange between the surfaces may be black surfaces, in between black surfaces, in between non-black surfaces. We are going to understand and derive the equation for Planck's law of radiation, how to find the total emissive power, what is gray body, what do you mean by Kirchhoff's law of radiation, what is Wien's displacement law, what is the shape factor, and with the help of electrical network method, we will derive the relation for radiation exchange between the two gray bodies and what are the radiation shields. What is radiation? Radiation is the mode of heat transfer in which heat is transferred due to the property of the material to emit and absorb EM waves, electromagnetic waves, and the emission of energy is due to temperature, due to its temperature. It is very difficult to provide a simple physical picture of something which is quite invisible. The transfer of heat from one body to another without any transmitting medium is one of the wonder of the nature. The radiation is different from conduction and convection because it requires no medium, and the amount of energy transferred by radiation is directly proportional to the fourth power of its absolute temperature. There are two theories, or we can say two theories are there which explain the transfer of heat by radiation. Those two theories are known as, first one is Maxwell's theory, second is Planck's theory. According to Maxwell theory, energy radiated by a body is in the form of electromagnetic waves, and there is a relation between lambda, which is the wavelength, nu, which is the frequency, and c is the velocity of light. Lambda is equal to c by nu. The value of c, which is the velocity of light, is equal to 2.99 into 10 raised to power 8 meter per second. Both theories are useful. The Maxwell theory is used to predict the radiation property of the surface. According to the Planck's theory, energy radiated by the body is in the form of photons, in the form of packets of energy, and those packets of energy are also known as quantas. Energy emitted by a body E is equal to h multiplied by nu, where h is the Planck's constant. The value of Planck's constant is equal to 6.6256 into 10 raised to power minus 34 joules second. Okay, let's start with the next topic. To understand the surface absorption, reflection and transmission, we are going to draw a diagram. The diagram is like that. We have a solid surface upon which some amount of energy is incidenting on the surface. That amount of energy is Qi. It is striking the surface. Now what will happen to that Qi amount of energy which is incidenting upon the surface? It is divided into three parts. The first part is the energy which is reflected, and it is Qr. The second part of the energy is the energy which is transmitted, and it is represented by Qt. And the remaining part of the energy is absorbed by the solid body or a surface, which is represented by Qa. In the equation form, how we can write down? In the equation form, the total energy, which is the incident energy Qi, is a summation of energy absorbed, energy reflected, and energy transmitted. If we divide this equation by the total energy Qi, Qa divided by Qi, Qr divided by Qi, Qt divided by Qi will be equal to Qi divided by Qi. And it will take the form of another equation in the new variables, and those variables are known as alpha, r, and tau. Alpha is the absorptivity, rho is the reflectivity, and tau is the transmissivity. The energy, which is the fraction of energy which is absorbed by the surface, is known as absorptivity. The fraction of energy which is reflected by the surface is known as reflectivity. The fraction of energy which is transmitted by the body is known as transmissivity. Properties alpha, rho, and tau varies. What will happen if rho is equal to 0 means the reflectivity is 0, tau is equal to 0 means transmissivity is 0, and the total energy which is coming toward the surface is absorbed, then it means absorptivity is equal to 1. That type of body is known as black body. What will happen if alpha is equal to 0, tau is equal to 0? What is the meaning of alpha is equal to 0? The meaning of alpha is equal to 0 means absorptivity is 0. The meaning of tau is equal to 0 means transmissivity is equal to 0. If the total energy coming toward the surface is get reflected, then R will be equal to 1. If condition is such that that type of body is known as white body. The third case, if the total energy coming toward the surface passes through the body, then the tau will be equal to 1, means the total energy coming toward the surface passes through the surface, then rho will be equal to 0 and alpha will be equal to 0. That body is known as transparent body. Reflection of radiation. The reflection of radiation energy is known as specular reflection when the angle of reflection beta 2 is equal to the angle of incident beta 1. The reflection of radiation is known as diffused reflection when it is reflected in all directions. There are a few definitions in this chapter. The first one is very important definition is the emissive power. Emissive power is represented by capital letter E. The definition of emissive power is it is the amount of energy released or radiated by a body per unit area per unit time. And the units of emissive power are watt per meter square. The second definition is the spectral and total emissive power. At a given temperature, the total amount of heat energy emitted by the surface in all directions over entire wavelength per unit area per unit time is known as emissive power. Emissive power depends on characteristics and temperature. If E is the emissive power, it is a function of a few properties, wavelength and temperature. The units of emissive power is watt per meter square. To understand the variation in between lambda, lambda is the wavelength, and E lambda is the monochromatic emissive power, there is a graph in between these two parameters. Area under the curve, area under this curve, the total area under this curve for a given temperature T, the total is represented represents the total emissive power of the surface. The entire range for the wavelength varies from 0 to infinity. The emissive power of the surface Now the emissive power of the surface over the wavelength ranges from lambda to lambda plus d lambda, ranges from lambda to lambda plus d lambda is given by dE, and it is equal to E lambda multiplied by d lambda. Now what will be the total emissive power? Total emissive power over entire wavelength can be represented into the form of integral. When we will integrate this equation from 0 to infinity, there will be an equation for total emissive power which is represented by capital E. It will be equal to integral which varies from 0 to infinity for E lambda d lambda. Okay, we have done what is emissive power. Now emissive power is represented by capital E. It is represented by capital E. You will find capital E in the form with subscript lambda, which is E lambda, and you will also find this capital E with subscript B and lambda. What is the difference between these three types of capital E, which is known as emissive power? If capital E is represented as simply capital E, then it is known as emissive power, which is a total emissive power. If there is a subscript lambda with capital E, then it is a emissive power which is known as monochromatic emissive power. Now what is monochromatic emissive power? It is the amount of energy radiated by the body per unit area per unit time for single wavelength, or we can say per unit wavelength. The last one is the emissive power which is for black body, and it is a emissive power. It is a monochromatic emissive power of a black body which is represented by symbol capital E B lambda. It is the amount of energy radiated by a body which is a black body per unit area per unit time per unit wavelength. There is another definition which is known as emissivity. The symbol for emissivity is epsilon. What is emissivity? Emissivity is the ratio of emissive power of a simple body, emissive power of a body to the emissive power of a black body. There is another definition of emissivity which is known as monochromatic emissivity. When you will find a symbol epsilon with subscript lambda, that is known as monochromatic emissivity. The definition, or we can say we can define monochromatic emissivity, which is epsilon lambda. It is the ratio of emissive power, monochromatic emissive power of a body to the monochromatic emissive power of a black body. Now the next topic is what is black body radiation. We know a black body is defined as a body which is a perfect emitter and perfect absorber. Okay. It has an ideal surface with the following properties. A black body absorbs all incident radiation, all types of waves of radiation from all directions at all wavelength. Second important point about the black body is that at a specified temperature and wavelength, nobody can emit more radiation than a black body. Third one, the emissive power, or we can say the energy radiated by the black body, is a function of wavelength and temperature, but it is independent of the direction. Black body neither reflects nor transmits any amount of incident radiation. What does it mean? It means reflectivity is equal to 0 and transmissivity is equal to 0, and absorptivity will be equal to 1. Now the next topic is Planck's law of radiation for spectral distribution. What is this law? This law is given by the Planck's in the form of equation. This equation is in the form of monochromatic emissive power, lambda, and temperature. Or we can say that emissive power of a black body is a function of wavelength and temperature. Where C1 and C2 are two constants, their value is given as 37.45 into 10 raised to power 17 joules meter square per second. C2 is equal to 1.438 into 10 raised to power minus 2 meter Kelvin. There is a plot in between EB lambda and lambda. EB lambda is the monochromatic emissive power of a black body. Lambda is the wavelength. When you will change the value of lambda in this equation for a particular temperature, let's say for T1, there will be a smooth curve like this. Now if you change the value of temperature, if you raise the temperature from T1 to T2, there will be a second curve, and similarly we can draw other curves. What is the explanation of this Planck's law of radiation, which is for the spectral distribution? We can say that the variation, or we can say the plot in between EB lambda and lambda, suggests that the spectral emissive power of black body is a continuous function of wavelength. It increases with the wavelength. First it increases with the wavelength, it reaches to the maximum value, then decreases. At any given wavelength, the emissive power increases with the increase of absolute temperature. What does it mean? It means the value of peak of a curve, it increases with the increase of temperature. The next conclusion we can conclude is that for each curve, peak value of emissive power, there is a peak value of emissive power. As the temperature increases, the peak shifts towards the smaller, in the direction of smaller wavelength. The peak of the solar radiation or a black body radiation is at temperature T, which is equal to 5800 degree Kelvin, which we are going to assume that the temperature of the sun.